your host Trey, and today we're going to talk about elementary programming. So, without wasting any of your time, let's get into it. So, today we're going to talk about the types of errors and some other things that you will find useful. So, we have syntax errors, and I'm pretty sure you've seen this word before, syntax, or using a calculator or whatnot. You have seen somewhere between your life you have seen syntax errors. So we're going to talk about what syntax errors actually are, and we're going to talk about everything about that. So a syntax error is a type of error that occurs in a program when the code violates the rules of the programming language's syntax. I'll give you an example later on, but in other words, the code does not conform to the structure and the grammar specified by the programming language. Let me give you an example in the ruled syntax. So you are familiar with Microsoft Word. I'm pretty sure you are. And if you write a wrong sentence or a wrong word, you will get something like this. And with this, you can see that this is not a real word. Well, it is, but the programming syntax or whatever you write down, this is not a real word because you this is one word that has got I don't know how many characters that are there, but with Microsoft Word, it will not recognize this as a real word that is in the English dictionary, right? So basically, you cannot start with a small letter in the syntax or in the formation of an actual sentence in the English grammar because that's just the English grammar the way it's structured, right? But also, more importantly, this syntax and errors are two different words. Like I've done here, there is a space in between. So there must be, or there should be, a space in between to make this sentence actually make sense in Microsoft Word. So that is basic. That is a basic syntax error in the English grammar. You cannot start a sentence with a lowercase letter. That's just not the way. That's not the way it goes. Um, you cannot say errors with one R, or you cannot say syntax without the tax, or you cannot say syntax without the A or the Y, and all that, and so forth and so forth. So that's basically what a syntax error is. It, it's an error that does not conform, or this is syntax or words or basic basics that do not conform to the structure and the grammar specified by that actual language. So these are syntax errors that are typically detected by the Java compiler or the interpreter during the compilation and the interpretation process. And they prevent the program from being executed until they are fixed. So until you fix your syntax errors, you are not going to have your code executed. So syntax errors are generally easy to identify and fix compared to other types of errors such as logical errors or runtime errors. The compiler or interpreter usually provides error messages that point to the location of the code where the syntax error has occurred, making it easier for the programmer to actually correct the mistake. So you are not completely out of luck because the compiler is going to tell you, hey, you've got a problem here. Just like many text editors or just like Microsoft Word will tell you that, hey, this is not what it's supposed to be. This is a wrong sentence. The Java compiler is going to tell you, hey, you have made a mistake on this line. Fix it, or else this code will not run. So that's how the compiler actually communicates with the code itself. It will tell you, say, hey, this line on this line is an error on this line and at this point. And as you write your code, you are going to see where that error is, because I'm definitely sure you are going to encounter syntax errors later on down the road. So here are some basics that you need to be aware of. First things first, you do not declare public with a capital letter P. That is very, very important. I did not mention it here. I don't know why I did not add that here, but this is a very important key concept. You do not, and I repeat, you do not write public with a capital letter P. This falls into the case sensitivity I talked about last video, and I will say it again. Java is case sensitive. So everything that requires small letters has to be in the lowercase letters. Anything that requires uppercase letters always has to be in uppercase. And I'm going to keep on repeating this over and over again so that you do not make mistakes. So, if you have misspelled keywords, which is using incorrect spellings for programming language keywords, let's just say public without saying public, right? So it's supposed to be public rather than public. Missing or mismatched parentheses or brackets. So you could have something like this. We'll talk about ifs in selection videos later on down the line. Unclosed strings. We talked about what a string was, and strings are basically declared using these double quotation marks. So if you do not close, you do not open the quotation marks and close them, you have an unclosed string error, and this is a syntax error. And we've got incorrect operators. This is technically a runtime error, but we're gonna deal with that later on. And then we have invalid declarations. So we have things called integers and data types in Java, and notice that this is an integer, but then the output is a string. So this doesn't actually make any sense because you're trying to assign a string to an integer, which doesn't make any sense. So these are some of the syntax errors that you will find in Java. There are a lot more, but these are what the basics actually are. So, like I said earlier on, Java is case sensitive. This means it's very picky when it comes to how you write your code, and this is a very, very important point. So here's some basic syntax you need to be highly aware of. So, like I said earlier on, you do not start public with a capital letter P. In the Java syntax, public is always in lowercase. So as class, and string is a different case. String throughout Java is kind of like a wild card. It doesn't conform to any of the syntax. It's a different breed, right? So string starts with a capital letter S rather than a small letter. So every time you want to declare a string, you have to always have this guy here. If you declare it with a small letter, your program will not run because you won't know what that is. So anything that prints out a string, anywhere you're gonna see system.out or system.in, we're gonna talk about later on. System, wherever you see system in Java, the S is always capitalized. So with string and system, always capitalize the S. So we have system.out.print and system.out.print here. Another syntax error that I forgot to write down is the creating spaces between system and out or out and print. There should be no spaces in between these two guys. So you just have system dot out dot print, just like that. And then we have system dot out dot print, and we have this is our correct syntax using our double quotation marks to invoke a string literal, right? And then we have this guy here where you have an enclosed string, and also these semicolons. So these are very important. If you miss these, then your code will not run. This basically tells the compiler, say, hey, so this is the instruction that I've given you. This is it. Nothing else. This is it. So if you forget to tell this, then Java will tell you, hey, what about this line? What do you want me to do with it? You know, like it will give you a syntax error and it will tell you, what do you want me to do with it? Like, is this an instruction? Is this a method? Like, what do you want me to do with this actual line of code? You get the idea. Alright, so with that being said, let's look at the other types of errors, which are logical errors. And these are errors that don't typically display what you wrote the program to do. Essentially, when input is not equal to output. So here's a sample code of the logical error. And then we have public class logical errors, public static void main string args, and we declare 5 as an integer. We'll talk about data types later on in the future videos, but let's just go with it. So we have 5 and 10. So we declare 5 equal to 10 and y equal to, sorry, x equal to 5 and y equal to 10. And then we also declare this value as a result and we say x divided by y. Normally, we are going to get 5 divided by 10, which is 0.5, or 1 divided by 2, right? So decimal form is going to be 0.5. But then when we declare our output here, say system.out print, the result is our result, meaning we call out this guy to be in our output statement there, we are going to get something like this. So if we go to our desktop where we saved our code and we say Java, then we say logical errors.java, we are going to get something like this. So we see that our result is 0, right? So the result being 0 is not exactly what we want because we want 0.5, not 0. This is due to a term that we use in programming called truncation. And truncation basically is that when you declare something of a certain data type and the result of that declaration doesn't conform to the data type, it will just output the exact data type that we declared it to, right? It doesn't make sense now, but wait, I'm gonna explain in data types later on in videos. But just now, we're just talking about logical errors and the types of errors that are there. Okay, so now that we've understood what logical errors are, basically when our output is not equal to what we put in, we talk about runtime errors. And these are errors that cause the entire program to terminate, essentially when you have illogical syntax. So here's a sample code of runtime error. We have public class runtime errors there, and then we have something of the same format. But we say int x is equal to 1, and then we declare y as 0, and then we have the same operation, where x divided by y. So in the mathematical syntax, right, 1 divided by 0 is undefined. If you go to your calculator right now and say 1 divided by 0, this is an undefined. It will give you a math error or a syntax error depending on what calculator you're using. But if you output this value here in Java, you're going to get something like that. So if we were to run our code and say Java runtime errors, we are going to get something like this. So we see that we have an exception in thread main, java.lang arithmetic expression, divide by 0 at runtime errors main, error 9, and so on. So every time you see exception in thread main, you know that you have a runtime error. So meaning you have illogical syntax that you have declared here. Because honestly, you cannot divide by 0, right? So same thing with a string and same thing with an array. You are most likely to get an exception in thread main because you have used illogical syntax of what essentially is supposed to be. So just to recap on what runtime errors are, these are errors that cause the entire programs to terminate. Yeah. So with that being said, let's go to our language and the types of common errors that programmers make. I am not an exception. I've made these errors countless times. So before we get into that, we talk about the language, and we have curly braces, and these are used to encapsulate everything within a class. Like I said earlier on, we have this class here. Everything that is within this operation here is encapsulated by this class. Remember, in our introductory video, we talked about what classes are and how they actually operate. They act as some sort of container. So when you talk about the glass and water, when you put water in a glass, the water is contained within the glass, right? So meaning everything that we write in our code here is going to be contained within this class. So that is what a curly brace is used for. And a semicolon is used to end the coding line or statement. I think I explained that earlier on. Parentheses are used to encapsulate arguments within a method. So like this method here, string args, or this method here, the printline method, it's used to encapsulate these guys here. So every time you want to have a method, you always start and end with the parentheses. Okay, so we have a double slash, and these are used for comments. Like you see here, 1 divided by 0 is undefined, and you can see that that line of code has not been written anywhere within our output because the Java compiler will simply just ignore this line of code, right? And then we've got quotation marks used to enclose strings. And then the common errors are forgetting a curly brace, forgetting a semicolon. This is the most common one. I've fallen victim to this one so many times. Forgetting parentheses and forgetting a quotation mark. These are all simple and common errors that you'll find in Java. And don't be discouraged when you have a syntax error, or maybe you receive error messages, over 100 error messages. Most of the times, 100 error messages can be just caused by forgetting a simple curly brace. Trust me, it's happened to me so many times. I have written code and I have like maybe over 200 lines of errors on my compiler and the command prompt, and then the only remedy to all that was just adding a curly brace because I forgot to do that. So these are the common errors that programmers will find. Yeah. So with that being said, some important notes. And with Java, all you must know are two important concepts: the concept itself and the syntax on how it's executed. So if you know that the printline method is used for printing out to the command terminal, or it enables us to see our code or the output of our code, then you say, okay, yeah, that's how the system.out.print method works, but then how do I invoke it? So that is what syntax is. So with Java or any programming language, you need to know the concept and how to declare it. Simple as that. Alright, so we're still in elementary programming, and now that we have gotten the errors out of the way, we're going to talk about data types, variables, and libraries found in Java. So elementary programming, we're going to go through a few basics. Some of them are syntax, and we have data types, also known as primitives. So depending on if you are watching this video to learn programming, or you're watching this video to, or you have a course at your university or college, depending on who is lecturing you or teaching you, they will use either data types or primitives. So it's better to know that these two mean the exact same thing. So the type of primitives or data types that we find in Java are as follows. So we have our name, programming name, description, and example. So integers in the real world, we know what integers are: 1, 2, 3, 4, 5, 6, 7, all the way up to 100, right? Or even all the way up to infinity, depending on how far you can count. So the programming name for an integer is int, and these are integer data types, right? So notice that an integer in the real world cannot be 1.5, because 1.5 is basically a fraction that is rewritten in a different format, right? So an integer is basically 1, 2, 3 whole numbers, so to say, right? So the same concept in mathematics is the same concept here. And integers are 1 all the way up to 1000. You can declare it as much as you like and all that there. Then a double basically is a fraction until one decimal point, right? So like we have in mathematics where we say 1 divided by 2 is 0.5, this is what is known as a double in Java. So it's declared with all lowercase doubles there, and these are real numbers fixed to one decimal point. So we have 1.0, 2.0, or 2.2, 3.4, and 100.3. So earlier on I talked about truncation, and if you remember the logical errors, truncation, like I explained earlier on, is when we declare something of a certain data type, but then what we've declared does not conform to that data type. So it will automatically give our output conforming to the data type that we declared it as. So remember, we declared it as an integer, right? And we said 5 divided by 10, which was which we were supposed to get 0.5, but we got 0, right? Good. So it's truncated the value to get the first digit or to get the data type that we wanted, right? So if we were to declare that code using a double, we would have gotten our 0.5 rather than getting a 0. So that's one way of dealing with logical errors anyway. So floats basically the same as double, but then when you say a float could be a number like pi, 3.1437 continuously goes. So meaning these are real numbers that have no fixed decimal point, and the decimal point floats to different positions, and it can move here or there, and here or there, depending on how you have declared your arithmetic stuff. So the syntax to use is float, there, all lowercase, and this is what an example of a float will look like. So the difference between a double and a float is that a double is only fixed to one decimal point, and then a float has no fixed decimal points. All right. So strings, I've explained what a string is majority of this video, so I'm not going to talk about that. And characters, it has the syntax of char or char, depending on how you pronounce it. But this displays a single character. And the syntax on how to declare it, notice that we have a single quotation mark, whereas in a string we have a double quotation mark. You can put a single character in a string, but you cannot put a string in a character. So a character is specifically just one character, so on and so forth. Okay, so with that being said, we talk about the Java libraries, and there are many libraries in the Java class, in the Java development kit, but we're going to talk about one specific that we are going to be interested in. So I got the Java .lang. So this dot operator helps us call these methods, right? So this provides fundamental classes like objects, strings, and basic language features. And the Java.util, this is the most important one that we're going to use throughout everything here, and contains utility classes and data structures like collections, date and time, so on and so forth, right? And then Java.math includes all classes for arbitrary precision arithmetic. So you can use arithmetic operations quite alright, yeah, but then there is a math class that is embedded within the Java development kit that is used for precision mathematics. So yeah, there's that. Okay, so with understanding these libraries, we're going to talk a little bit about scanners. So have you ever wondered how you can input your password and you can log into applications like Facebook or Instagram, or maybe even log into your Google account, right? So these are done using scanners, and that's how scanners work. And quite frankly, these are one of my favorite things about programming, because these allow you to interact, or allow the user to interact with the program in question. And we're going to see how these scanners work in selections in the next video. But just know that these scanners allow us to be able to input values so that the code actually puts out our values. So Java provides a diverse library containing different classes that do so many different things. And we'll learn about some of those classes later on, but in this lesson we're going to learn and we're going to discuss about the scanner class, right? And to declare or call the scanner class, or any class at that, you use the import method to call any class from the Java library. And I'm going to show you how that is done. So like I said earlier, Java, you know the concept behind it and the syntax. So with scanners, we have known, say, okay, scanners are used for this, and that. Now we're going to look at the syntax on how to actually call this scanner. So we have 3 steps on how to implement a scanner. So first, you import the java.util.scanner. Remember, I said that the util class is very, very important, and the util library, sorry. And we say in the java.util.library, we have scanner. So just like you have sections in a library, you say, where's the arts and crafts section in the library? And then the librarian is going to point at you, say, go there, that's where, or maybe it's an aisle 9, or aisle 10, or aisle 5, whatever. Then you go to aisle 5 and say, okay, I'm looking for this exact book. So I find this book. Oh, great, I found it. So it's the same concept here. So the you are the programmer, right? The Java compiler is the librarian, and you say you want a scanner. So you go to the compiler and say, "Hey, I want um, I want a scanner," right? So the Java compiler is going to say, "Oh, okay." It goes to the library and say, um, "Okay, here's the scanner," and then it takes it back to you and says, "Here you go, one scanner for you." So how to actually implement that is import java.util.scanner, and then you close the statement. So like I said, instructions, instructions, instructions. This is used to close off instructions. So when you say import java.util.scanner, you close this guy and say, okay, yeah, that's that. So the Java compiler is going to import from the Java library the scanner, right? Great. So for you to be able to use this scanner, you say scanner input is equals to new scanner system.in. So like I said, system, wherever you see system, always capitalize the S. But then this is a class. This is a name of a class, which is called the scanner class. And whenever you are importing a class, um, it always has to be capitalized. Always. A class is always capitalized. Always. This is different from the this is different from the class that we talked about in the writing the first program video, where you have a name of a class. But this one is embedded within the Java library. So these have predefined names, and all the predefined names start with a capital letter. So there are a lot of other things, and when you reach object-oriented programming, you're gonna see what I mean. So this is our object inputs, right? So this is a class, and this is our object. Remember, we talked about objects, and then we declare it, say, equals to new scanner, and then this scanner has got a method here, which is system.in, right? And then we close this instruction. So meaning now we have said, okay, whatever we are going to, or whatever the user is going to input in this program, you are going to receive it, and you are going to do with whatever I'm going to tell you on later on, right? So now you prompt the user for input. So when you put a system out of print line there, you prompt the user how to actually declare that, how to actually get what you the output from the input. We say input dot next, and then we have our open and closing parentheses there. So this is the basic syntax of using scanners. We've got the inputs, we've got the object, and then we've got the prompting the user for inputs, right? So here's the sample code. We have import java.util.scanner, close that there, and we say public class test scanner, which we have the opening brackets there, and then we have our methods there, and then we create the object for the scanner class. So we say scanner input is equals to new scanner system.in, and then we prompt the user for input and say system.out.print what is your name. So when we say what is your name there, we say string, right? Remember, declaration of string, use a capital letter S, and then here we declare the string, or we declare name as a string. So we say string name is equal to input.next, and then we close that. So like I said, string is basically kind of like a wild card. It doesn't conform to the normal convention of majority of the data types, because it's kind of like the rebel in the group, that one bad apple. So for string, you just say input.next, and then you open and close the parentheses, and then now you output your information. So you get system.out.print line, wow, plus name, plus you have a really beautiful name. So here's the outputs for how you actually would see this. So you got java.test scanner, right? And then we have this interaction between you and the code. So what is your name? And I will put in my name, which is Trey, and it will output, wow, Trey, you have a really beautiful name. So notice that what I have done here, at this point here, I haven't put my name, but I have put Trey, which I have input using this string method, or this input method, whatever we put in as a string, or whatever we declare as input there, it will be output in the print line method. So we have wow, which is wow there, and then we have Trey, and then you have a really beautiful name. As you can see, that's how scanners work, and you can play around with this as, yeah, they're really cool. So like I said before, strings are basically wildcards. So let's look at this type of scenario. So our sample code 2, we import the scanner, and then we create the object for the scanner class, right? Where it talks about all this. And then let's just say, this is the other print line, what is your favorite number? So here we have double number equals to input.next double, right? So when you are declaring a double, anything that is not a string, you have to input it as next, whatever that data type is. But then, when you are naming it as that, you say next, and then you say the whatever data type you're going to put, the first letter of that data type must be capitalized always. So you're going to have next float, F is going to be capitalized, next int, I is going to be capitalized, next character, C is going to be capitalized. So we have our code here, sits in the outer print line. Wow, number is a very lucky number because that's our code. So let's look at our command prompt there, and then we type in Java test scanner 2, and we have that guy there, and then our output, we should have that guy, which is what is your favorite number. And if I say 7, notice the difference in data types. So like I said, doubles are values that are fixed to one decimal point. So if you declare any number as a double, it will give you a value, which is that value that you have put in plus fixed to one decimal point. So it will give you 7.0 if you declare it as 7. Notice that I haven't put any 7.0 there, but it automatically changes to 7.0, right? So that's how the things work. And then int, like I said, int, same program, same everything, and then we have int there. And then we see our output, which is test scanner 3.java, and we run this code. And then we have our output, which is what's your favorite number, 7. And then notice that because we declare this as an integer, and like I said, integers are basically real numbers. They do not have any fixed decimal point or whatnot. So we have wow, 7 is a very lucky number. So here, this 7 is what is output there. So this is the syntax for putting integers. The previous one for doubles, and for strings, you just say input.next. You open and you close that there. All right. I think finally we're going to talk about identifiers and variables. And an identifier is a name that identifies an element, such as a class, method, or variable in a program. Think of it as the same name you would give when naming a dog or a child. The name you give is an identifier that helps you distinguish one from the other. So you can have twins, right? What distinguishes the twins between the two is one is Kate and the other one is duplicate. And you get the idea. So an example of an identifier is age, right? You declare age as an int, double as height, float as width, string as name, character as letter. Then a variable is a data type used to represent values that may be changed in a program, right? You can change these variables depending on how you feel like changing your code. For example, we could say int. Int is a variable or a data type, right? So int is a variable, double is a variable, float is a variable, string is a variable, chart is a variable, right? And an identifier must start with a letter. So identifiers, these guys, must start with a letter, underscore, or a dollar sign, but must never start with a digit. An identifier cannot be a reserved word, meaning true, false, or null, and an identifier can be of any length, right? You can have 1,000 characters in your identifier. Your program was to be that. You just have to make sure that you write, yeah. So Java is case sensitive. So area, and area are completely different identifiers. Because if you say area, and area, these are Java is case sensitive. So it reads this as that, and this as that. So if you have three areas in your code, that's that. Because these three are different from each other, according to Java, that is. So assignment statements are the same as mathematics. If 1 is equals to 1, then 1 is 1, right? If the square root of 4 is 2, then that's what it actually means, right? Great. So we're at the end of the video, and like I said in the previous video, this is an interactive course. So I'll give you an exercise to write a program that shows the output of the different data types that I showed you earlier on. Try to have fun with it, and like I say, the more you practice, the better you are at programming. And that's the exercise for you in this video. And next up, we're going to talk about selections. So I will see you in the next video. I hope you take care and stay blessed.